Okay, thank you. So, as you might already know, my name is Nikita. I work with the Safe Client Libs team to build the highest level of the network that applications rely upon. And today I wanted to touch to several topics, and as a first thing, I wanted to define our goals that we have for the language and platform support. Because currently, as Krishna have said, our kind of main application language is JavaScript, and it is one of the most popular languages out there, of course, and it is supported on mobile platforms, on the web, and you can build desktop applications with Electron and so forth. But of course, just having the JavaScript support is not enough, because there is a lot of developers who prefer other languages, and there is also other languages that are native to other platforms, like Java for Android, for example. So people who prefer other languages and who want to use other languages should be able to build their applications that interact with the safe network. And we want to provide the support for them as well. So our end goal is to provide Safe Network API for applications for, I think, most of the major languages, but our focus for now is on Java, C#, and JavaScript, and I will talk a little bit about that later. And apart from languages, there is also aspects of the platform support, because so far we have been focused mostly on the desktop platforms, and in the developing countries, most of the people that are starting to use internet, they don't use desktop platforms. They use mobile platforms, they use tablets, they use smartphones, and I think it is very important to allow these people to use the Safe Network, the applications that were built for the Safe Network. And we want to support developers who want to build applications that work on mobile platforms as well. And one of the most important points I want to bring up is that, of course, we also want to continue supporting Rust as a language for apps development, because currently there are not a lot of documentation for developing apps in Rust, and coming forward we want to write new tutorials. We want to improve documentation specifically about developing your applications in Rust, because all of our libraries are in Rust, and it's it might look kind of weird that to develop applications in Rust you have to use FFI functions, and we want to provide better support for native Rust applications. So coming forward, these documentation should be available on the Dev Hub, and we want to add a whole new section basically devoted to Rust. So what is our current state of things with the language support? Starting from from SafeCore, from the launcher times, we have constructed our API as based on the concept of foreign function interface, or FFI. It is based on the CABI, or application binary interface, that is a kind of lingua franca of all systems development. So consequently, as Krishna mentioned, I think that was one of the questions about it. I think the vast majority of languages support CABI. So in practice, that means that if we have a C-compatible library and C headers, consequently, we have support for most of the languages out there. And if the community members are interested in providing support for other languages, they're free to do so. And it should be, our goal is to make it easy enough to provide support for newer languages. And we are seeing some great examples. So the dev community on the dev forum are doing a great job on providing support for Python bindings, for example, and we're hoping to see more examples coming soon. So, through the foreign function interface that we have, it is mainly used by Node.js now. But as our goals have changed, and as we wanted to support mobile platforms and add support for new languages that are native to these platforms, we have developed new requirements for safe client libs. And it took us a considerable amount of time to find a suitable solution, because we have tried to develop several proof of concept projects, starting from the approach to build the bindings manually, but it didn't work out so well, because we quickly found out that the approach to manually build the bindings is very tedious and error prone, because we have lots of functions in safe client libs, like maybe a couple of hundred, and it is very possible that we add new functions to our API. So to define all of them manually for every language that we want to support, for Python and Ruby and so forth, we might have needed to code that manually, but we don't need to do that because it is error prone. If something is changed on our API, or you might have, while developing the manual bindings, you might have forgotten to put some parameter there, and it's very hard to catch that error. So we started to look to some of the existing tools to generate bindings automatically. One of those tools is Swig, and I think it's one of the most commonly used ones in this area. Like what it does, it takes kind of a description of the interface of the library, and given that interface, Swig can build bindings for all the platforms that it supports. So if I'm not mistaken, the built-in support in Swig is for, at least for Python, and Java and C#. And we tried to use that, but it didn't work out so well in the end too, because eventually we found out that Swig is not very suitable for our specific needs. Because the Safe Client Libs API is constructed in a very specific way, because we follow our own set of conventions, and on top of that, it's not only like how we name our parameters, it's not only how we define the placement of those parameters in functions, and it's not about like how we name our functions, it's also about asynchronicity, which adds an extra layer of complexity on top of the API, because in Safe Client Libs, some of the functions you call will not provide the result immediately. It might be provided after a while, because this function might need to go to the network to fetch the data or to send the data, and it will be provided through the callback. And that is the convention that we follow for asynchronous programming in kind of C ABI. That is a whole another story, how we invented that convention, because it's like we stumbled upon so many bugs related to that, so many memory management bugs related to that, but eventually we found a solution that works pretty decent. But the problem with that solution is that the existing code generator approaches don't work so well with that approach. Another problem with Swig was that the code that it produced was not something that we wanted, because it uses a concept that is called directors, and the code that it generates doesn't feel very native. So, for example, if you generate code for Java, the end users of that Java API will not be will have an API that is not very idiomatic for Java. And we wanted to have something more modern, something that makes it possible to use, for example, lambdas for callbacks. And we don't want to use the data API. So ultimately, we decided to take another path with the binding generator approach. We followed the idea of building our own in-house code generator framework. We based it off of the Mozilla project that is called Moscheddar. Moscheddar has a very similar goal, but it supports only the C language. So we wanted to kind of do the same thing, but for supporting other languages as well. And the basic idea here is actually very simple. We basically take a part of the Rust compiler that parses the code and outputs the special structures that are called abstract syntax trees, or ASTs. And given those structures, we can extract all of the information we might need into, we might extract the function names, the parameters, the parameter types, and given that information, we can, based on that information, we can generate the actual code output. So in the end, it works kind of like, it kind of works like a compiler, but instead of outputting an executable binary, or executable library, it produces actually Java code or C# code or anything you might want to have there. So now Moscheddar is deprecated, but it's not recommended to use it, but as we have refactored a major part of it, it kind of started to be like our own library based on Moscheddar, so we intend to continue supporting that. And that was about the language support, but what about the platform support and the operating systems that we want to have? So there is a new thing that we define. We break the support for platforms into several tiers. And as a tier 1, we have all the platforms that we always had. It is Linux, Windows, and Mac OS. And what tier 1 means is that if something breaks during our continuous integration tests, we take it as a top priority to fix that error. And if the community reports that something is broken, that something doesn't work for them, we also take it as a top priority to fix that. And ultimately, we also want to have the tier 1 support for iOS and Android as mobile platforms. And there is also an extra announcement that we are discontinuing active support for x86, so 32-bit Intel platforms. And the major reason for that is that it takes effort from us to actively support it. It takes us time to react to the errors reported by the community. But the problem is that the number of users of that platform is continually shrinking, and actually operating systems like macOS actively discontinue their support for this platform too. But it doesn't mean that we take the x86 platform support and drop it somewhere we are not discontinuing it as such. We are just stop supporting it, and we still have tier 2 support for it. And in practice, that means that we won't kind of test and validate it, but it also means that we continue to run our continuous integration tests. But if something breaks there, if the tests during the CI process fail, we won't actively look into that. We might check that, but we won't take it as a priority. And likewise, if the community members report that something doesn't work for them on their 32-bit computers, we might look into it, but we won't devote too much time to do that. But also, that means that if interested community members want to fix something, they are free to fork our repositories and provide patches, and we will review them and possibly integrate them upstream. So for mobile platforms, we also support, we have support for minimal versions of Android, which is larger than 4.1. And we also support, we want to make it a maximum amount of devices to have support for. So we start with a minimum Android version that is used by most of the people. So we want to reach most of the people that use Android. We don't support very early versions that are not supported by Google themselves anymore. And we want to have a support for the minimal supported version by Google. And likewise for iOS, we follow the recommended standards by Apple. So we take versions that they support and we support them as well. And that is version iOS starting from version 10 or 11, which is currently supported. And we also do different architecture support for Android and iOS. And for iOS, of course, the main one is ARM64, but also x64 for simulation. And the same thing applies to Android, we support ARME version 7, which includes support for, I believe, higher versions and some lower versions. And we also support x86 for simulation too, and x64. And in addition to platforms and languages support, I wanted to touch on the topic that took us a lot of time to get right and to actually implement. And the team actually has done a great job in that, because we considered different approaches to this problem. And the problem is that previously, we didn't have so much complexity without having support for applications and authenticator. We didn't have such concepts, and now that we have them, we have applications authorization, we have application certification. We now register users and their default containers. So there's a lot of operations that kind of, on the surface, look like it is a single operation. So you register your account on the network, and now to you, it might look like it is a single atomic operation. In fact, it's not, because underneath, it is a lot of different sub-operations. And the problem with that is that each of those operations can fail. So we considered different approaches to fix that. And one of the approaches was to introduce transaction support on the network. But we quickly decided against this idea because it adds so much complexity that we don't have time to do that. So this problem by itself is can be solved by applying the transactional thinking. So the problem here, for example, if we take a case of user account creation, first we create a user account session packet, then we create default containers, and this all looks like kind of a single operation. But what if, for example, we have created a session packet successfully, then we have created the default containers, but at the step of creating the access container, which holds the information about applications on the network, what if we have failed in this step? Then basically, when a user tries to log in into his account the next time, he could be missing his access container. He could try to create a new account with the same credentials, and he could fail. So how do we fix this operation gracefully? So what we have devised is kind of a general approach to operations, to operations recovery. And this is not like a general approach that can be used by applications. And we have no a generic way of doing this thing yet. So we don't have this thing available as an API to apps. But internally, it is more of a framework that we use to fix those situations. And generally, we kind of do graceful error handling. So, for example, if someone can create his account or he can't create an access container, we consequently check if the access container actually already exists. And if it does exist, then we kind of update the information in the user's session packet. We set the address of this access container that has been already created. And if it doesn't exist, we create a new one. So generally, it follows the pattern of gracefully handling errors. There is another example that's kind of the most complicated one in Safe Client Libs, and it relates to revoking the app's applications, because it might look like a single operation from the standpoint of the user's interface, but actually it has so many parts to that, and some of the parts have their own subparts. So we got to be careful about that, and we got to break down each of the steps and basically make sure that if some of the steps fail, we need to recover from them gracefully, so that when a user tries to revoke the application, and if the network connection fails, or if he or she runs from their account balance, what if like one of the operations of re-encryption fail? How do we deal with that? Because re-encryption actually subsists of several composite operations. We need to take each of the containers that this app had access to and basically apply new keys. So we're kind of changing the logs. And for example, app could have been removed from the client managers, and it could have been removed from the permissions list from these containers that it had access to. But still, it could have left with the encryption keys. So what if an app still has these encryption keys? We need to make sure that applications can't access this information and can't access those containers anymore, because they can know the location of these containers. So it was a kind of a complicated task to solve, but eventually we cracked it, and we did it by basically re-encrypting all of the containers. So changing the private keys, updating the private keys, and re-encrypting all of the information with the old private keys. And it is also a composite operation, and it took us a lot of time to figure it out, and the basic approach has been invented by Spandan and Adam, and it was largely implemented by them, and they did a great job on fixing this issue. But coming forward, we might see some, like we have provided just a couple of examples so far, but coming forward we can see many more of them. Like applications might have their own composite operations, and they also need to handle that gracefully. And it's still kind of an unsolved problem how to provide an API for applications to solve this problem, because users and developers might expect that we have a kind of a native support for composite operations, but we don't, and it needs to be handled on the application level. So in the future, we are looking forward to solving that on maybe kind of a more general approach from the app's perspective to provide an API to apps developers, and it still kind of remains as an unsolved problem. So that should be it, and maybe you have any questions on Safe Client Libs and on these topics. Thanks a lot.